Hi, this is Mark from LongIslandWatch.com, and welcome to another episode of Watch and Learn. Today we're going to be tackling regulating a wristwatch. Now, a lot of people have asked for this, and I keep meaning to do it. I finally had some time to do it. Regulating a wristwatch is quite easy. It's quite easy to also ruin the watch because you're really close to the balance spring. But it is quite a simple procedure. Once you know what you're doing, if you're not shy or scared about opening your watch, then this is probably something you can do with your mechanical or automatic with relative ease. You may want to invest in a timegrapher. You don't need one. You can just time your watch from day to day versus an atomic source to get how it's really operating. But really, regulating a watch is speeding it up or slowing it down. It's very different than adjusting. I don't adjust watches. Watchmakers adjust watches. Factories adjust watches. There's a big difference between regulation and adjustment. Adjustment is getting the watch to run the same way, whether it be in a what they call, here's a sample, dial-up configuration, dial down, and then you have crown down, crown right, crown left, crown up. Usually watches are regulated to, I already did it. See that? Usually watches are adjusted to 5 positions. Crown right being the position that they usually do not adjust in. Oddly enough, this is the position that a watch is always shown in. It's in a magazine or obviously in the showcase. But if you're a righty and you wear your watch on your left wrist, to get the crown to be like this, you'd have to hold your watch like this for a prolonged period of time, and that's the crown right position. It's a very abnormal position. When you're walking, your crown is down or up, depending if you're a righty or a lefty, or maybe you wear them on both wrists like me. So they usually regulate to the dial, adjust. I did it again. They usually adjust to the dial up, dial down, and then 3 of the crown positions. Those are your 5 positions. But a lot of watches like the Seiko is just adjusted to run in its flat position. To get watches that are adjusted in multiple positions is expensive. So they adjust for position. They can also adjust for temperature. And those have nothing to do with regulating the watch. That is playing with the balance. Maybe it has a screwed balance. They play with the spring. They do all their crazy watchmaker tricks to get the watch to run the same in all the different orientations. That is adjustment. Regulation happens after everything else is finished. The watch is done. It's complete. It's fully adjusted. Then you regulate. Because if you regulate and then adjust, well, then you've thrown off all your regulation. So regulating is the last thing that we do. So like I said, there's different positions that they adjust them in. But when you go to do your own watch, and as I'll explain later, you're going to see how you perform day to day with your watch, see how it performs for you, how many seconds fast or slow it is, and then you can use a timegrapher to gauge your progress. It's a very sensitive measurement. So if you're not steady with your hands, as with anything with watches, if you're not steady with your hands, I would advise against doing it. So I am going to use a timegrapher that I have, but I'm not going to go into the operation of it. I think that's going to be another watch and learn because as an engineer, it fascinates me. But the way the timegrapher works is it's listening to certain points of the escapement. It listens to when the impulse pin strikes the pallet fork, and then it listens for when one of the pallet teeth locks with the escape wheel. I believe it's like hit 1 and hit 3. There's usually like 5 major sounds that an escapement will make. It's listening to basically the first and the third, and from that it can calculate everything. Well, actually, just from the first one, it can calculate what the rate of the watch is, but you need the third one to figure out what the amplitude of the balance is, how much it's spinning, and also if there's any beat error. It is important to note that I'm using a timegrapher. I'm not a watchmaker. The timegrapher is almost like an idiot tool. A watchmaker may have a timegrapher, but more than likely they use something that's far more expensive, maybe on the order of 10 times as much money, because then they can use more like an oscilloscope function and they can listen to all the sounds. They can see the sounds on the screen, and then by looking at the various traces that the sounds make, a watchmaker can diagnose a movement. Does it need lubrication? Is one of the pallet stones sticking? Does it need to be cleaned, lubricated, whatever? So it's important to know the timegrapher is a great little tool for the hobbyists, I'll say, because I am indeed a hobbyist, just like probably most of you. I guess I'm not a watchmaker. So it's good for telling how fast or slow the watch is going. Or maybe you're in the buying and selling. You go into a flea market, something like that. I've seen, I know people do that as well. They'll time it before they buy it. Anyway, I'll get on my own wrist check. I'm wearing a Junkers Bauhaus chronograph. And then on the other wrist, I haven't worn this in a while, my Ulysse Nardin Maxi Marine chronometer. Feeling like a blue day today. Favorite color. Looks great. I totally adore this watch. Anyway, so let's get over to the table and check out how to regulate a wristwatch. So in front of you here, I have my timegrapher set up. It consists of the clamp. I put a watch on it. It's got a sliding clamp, as you can see. And you put the watch in it. Oops, not with the tag under it. You put the watch in it, and then you've got a display, which also acts as the processor for everything else. So these two are hooked into each other. And what this is doing is there's a little microphone in it. It's picking up the noises of the movement, certain noises. It's relaying that information to the little processor, and then the processor, uses the clicks to determine what the rate is going to be. And then if you enter the lift angle of the movement in, if you know the lift angle, it can calculate the amplitude and the beat error. I've touched on this briefly before. Amplitude is basically how much the balance spins one way as it goes back and forth, how much of a 360-degree arc it makes. Beat error is how centered it is. Is the tick the same length as the tock, more or less? And you want to have a beat error, they say, of half a millisecond or so. From half a millisecond to 1 millisecond, you may want to try to put the watch back into beat, but we're not going to cover that now. The timegrapher also shows you the beats per hour of the movement, and it figures this out automatically, or you can program it if you know it. It figures it out just by listening to it, and it can figure out that, this is a 21,600 beat per hour watch, or it's a 28.8. So it takes some of the guesswork. If you don't know what the movement is, it takes the guesswork out of it, and it figures it out for you. Then obviously inside there is a quartz oscillator that it's counting the beats of as well, and that's how it figures out if you're running fast or slow. It does it instantaneously. If you think about years ago, they didn't have things like this. They'd have to time the watch over 24 hours to see how much it really gained or lost. So quite an advance in technology, and now they are quite affordable. I'll talk about lift angle really quick. Lift angle is the angle that the impulse pin interacts with the pallet fork. And from that angle and listening to the noises, that's how it calculates the amplitude, and it also calculates the beat error. But we're not talking about that now. Maybe that's a future watch and learn. I'll show you how all that math works out. We're going to be looking at this far left here. This is the seconds per day, and then you can watch it graph. So the timegrapher, let's start it up. The timegrapher makes two lines, basically one for the tick and one for the tock. And as I'm talking, you'll see some stray dots here. That is me talking. It wants to be in a relatively quiet environment, so I'm kind of messing it up by talking. But you're seeing the back and forth of the balance wheel, and the two lines should be fairly parallel, and they should be on top of each other. And the closer the beat error is to 0, they will indeed be right on top of each other. So I'm going to stop talking for 3 seconds. I'll stop talking for a few seconds, and we'll let it do a clean sweep. So you can see it cleans up nicely once I start talking. It obviously picks up again. So this watch is running around 14 seconds per day fast. The timegrapher, these numbers here, is it's averaging how it did over the past 4 seconds or so. But this is the instantaneous rate. It's doing about 14 seconds per day. Watches, as I said, behave in different rates at different orientations. So if we were to just flip this down and be quiet for a second. You'll see now the watch is slowed considerably. You see that the curve went flat. So now it's looking at, about 3 seconds per day. Watches generally run slower when they're in the vertical position. Why? Oh, gravity is acting on it. Gravity is pulling on the balance wheel. It's pulling on all the friction points a little bit differently. So things do slow down a bit. So what's really important to note is that, you can put it on the timegrapher, and I could have adjusted it in this position when it was plus 14, and I said, okay, I got to get that down to 0. And then when I would have went to this position, I would have been slow. and any of the other positions I put it in. So what you really need to do as a user, is you need to record how your watch is performing for you on your wrist, over a couple of days. Look at it every morning and see how it's doing. Is it plus 30 seconds? Is it plus 20 seconds? Because at night you put it on the dresser, it's dial up, and then when you wear it, you're a lefty, you're a righty, the crown's in a different position. Everybody is different, and we're assuming you're not going to be regulating a Rolex which has been adjusted to 5 positions. These aren't, these are basically just adjusted into the one position that they're regulated in. And then you can use the timegrapher just as a flat reference to, as an absolute reference to lower or raise the rate and not worry about what it's doing in different positions. So let's say after wearing it for a day, day in, day out, after 3 days, you're averaging, 15 seconds a day. Well, then you'd want to come in and try to slow the watch down by maybe 10 seconds a day. No matter what the rate shows it is on here, you'd want to slow it down by that much. Wear it and then see what happens, and then you can come back and do it again, as many times as you want. If you time your watch day in, day out and find that today it's plus 15, tomorrow it's minus 20, the next day it's plus 30, then forget regulating it. You're going to be chasing your tail. The watch needs service. Something's up with it. So let's get into regulating the watch. So I'll pull it off the clamp. We'll take a look at it, and I'll show you what you want to touch and what you don't want to touch. And again, this is the Seiko 7S26. A lot of movements are very similar to it. The ETA is a little bit different. I'll bring an ETA up later and to show you how it is regulated. But all watches pretty much have a movable lever that you can regulate with, and we'll show you how to do that now. So obviously the back of the watch is off, and I'm obviously not too concerned about dirt and everything else, but you should be. I'll just rotate the wheel out of the way, and you can see there's the balance. And on the balance cock or the balance bridge, there is an etching of a plus and a minus. They really couldn't make it much easier. And that plus and minus makes the watch go faster and slower. And then if I really try to pull in close, there's a little indicator here, and it's tied to this lever. You can move this lever backwards and forwards. If I move it this way, I'm going to slow the movement down. If I'm going to move it this way, I'm going to speed it up. Plus and minus. Some watches have A and R. R is for retarding the movement. A is for advancing the movement. It's fast and slow. This one here, this is what brings the watch in and out of beat. It adjusts the beat error. You probably shouldn't touch it. Never touch it. Unless you really know what you're doing. And if you know what you're doing, then you're probably not watching this video anyway. So you're going to play with this lever. Now, what is, it's a good question. Why do they have regulation levers on watches? Well, watches are all made, this watch, at least in my hand, is mass production. And after all the pieces are put together, hopefully it runs, when it's centered, hopefully it runs, like it's supposed to within its specified plus 25 or minus 15 seconds a day. But, obviously it's not always, because manufacturing tolerances and everything differs. So this is an adjustment that they do at the end to bring the watch into specification. That's why watches have it. Not all watches have a movable stud carrier here to bring it in and out of beat. Some of them are fixed, and if they're fixed, that's obviously a much greater deal to try to bring it into beat. But they almost, at least everyone I've seen, has some kind of adjustable regulator arm. There's swan's neck regulators. There's all different kinds, fancy schmancy ones. This is just a run-of-the-mill. So what is the range of adjustment? Well, if you were to bring this all the way to minus and then all the way up to plus, you're going to be running it, I think it does like 8 or 9 minutes or so from min to max. So it's a really wide range. So if you can imagine, if this is 8 or 9 minutes from here to here, the slightest nudge is going to change this to a pretty high degree. So the order of the day here is gentleness and being very soft with it. Small adjustments, putting it back on the timegrapher and seeing what it does. So you want to move this arm with anything. It can be the edge of a tweezer, it could be a toothpick, but whatever you do, be very careful, because right here is the balance spinning, and then right below that is the spring, the balance spring, which is extremely, extremely, extremely delicate. If you pluck it, it's probably going to get tangled, and then you just need you need a new balance. So this is where you can turn it into a piece of garbage, like I like to say. So let's just say, before we were running I think plus 14 or something. So I'm just going to come in and I'm going to move it. I'm going to exaggerate it, but I'm really going to move it. So I moved it maybe a 16th or so of the turn. Now what did I do? By doing that, I moved the end of the spring, And I've basically made the spring a little bit tighter, and that will speed it up. It's called changing the effective length. You're obviously not changing the length of the spring because the spring is a piece of metal. But what you're doing is you're changing the number of coils in the spring. You're increasing the number of coils or you're decreasing the number of coils by extremely small amount, but the system is very, very sensitive to the number of coils in the spring. That's all we're doing. So let's put it back on the timegrapher and see where we are. So now we're back on the timegrapher and look at the rate. I moved it. You could see it, but it went from 14 seconds. It's now, well, what is that? 2.5 minutes, almost 3 minutes a day that I've sped it up by. Notice the beat error didn't change. It doesn't really change that much. The amplitude, nothing's really changing that much. It's just the rate. That little nudge that I made sped it up that much. So obviously that's way too much. So I'm going to take it off. I'll slow it down a little bit, and then we'll put it back on. Okay, so now I'm going to go in. I'm going to slow it down just a bit. You see I hit the balance? Because this is obviously not the way I usually do it in front of a camera. But I hit the spring and it stopped. But if you just take it and you just push it ever so slightly. I moved it a little bit. And you do this back and forth and back and forth. Ideally, you could do it while it's on the timegrapher. I just can't because I can't get my head over there. But we'll put it back on the timegrapher and I'll go back and forth. And when I get it to a happy place, I will start filming it again. So now I'm back on the timegrapher and I've got it going now to -2 seconds, 0 seconds per day. But that's just because it runs like that in the flat position doesn't mean that when it's on my wrist all day, every day, it's going to run, with that kind of a consistency. But, I've gotten it to a good rate. And the idea here is now I would wear it for a day, 2 days, see what happens, throw it back on here. Maybe I got to adjust it by, another half a dozen or dozen seconds or so. And so it's an iterative process back and forth because, again, it depends on the wearer. So let's stop this now, and I'll show you some other, a regulator on an ETA movement, just so you can check it out. So here's an ETA movement from an Aristo watch, and you can see by the balance, see it's spinning away there. Instead of, having a movable arm, we have a screw, and plus or minus is there as well. And this is an eccentric screw, and when you screw it clockwise or counterclockwise, you're moving this little piece here, and it's changing the effective length of the spring. It's the same thing. This is just, a lot more refined. Bigger movements cause less variation. So maybe you can tune it in a little bit better, but still it's the same idea. You're just changing the effective length of the spring. That those number of coils are going up or down. So because a lot of you are watch people, I threw my Yachtmaster on here just so you can see. I'm going to mute the speaker. It bothers me. Just so you can see what an adjusted movement will do. So this is obviously a chronometer. It's a Rolex chronometer. They call it superlative, so it's actually tighter than the +6 -4 seconds a day. But importantly, it's adjusted to several positions. So you can see, it's running a flat 5 seconds, which I don't know how much credence I put into the extreme accuracy of the machine. But you can just see when I move the position and let it settle back in, the rate of the watch, it's not 10. The rate of the watch, doesn't really change that much. That's what adjustment means. You move it from the horizontal to the vertical, crown up, crown down, crown left, crown right, dial up, dial down. The watch beat doesn't change. So I don't know if you can see that, if it's out of frame. Move it a little bit, let it settle back in, and the rate of the watch really rock solid. Barely a movement. So that's what it means when we say your watch is adjusted to a certain number of positions. Now, so those spurs that you see at the +16, that's just when you touch it, the microphone's picking up my hand, and it is taking all that into consideration. And it's calculated as extraneous noise, so it thinks it's going faster than it really is. Then after I take my hand away, it settles back in. So you can see, obviously, it runs quite well. This is one of the reasons you pay so much for a watch like this, because they get the movement running like this. To see a flat movement, obviously flat means it's running, really close to zero. The two really close parallel lines, running like a top. Difference between a high-end movement and a slightly lower-end movement. There's nothing wrong with the Seiko movement, but it's like driving in a lower cost car or a higher cost car with a better suspension. It just feels better. It just rides a lot smoother. So here the ride's a lot smoother on the timegrapher. So I think that's about it, and we will wrap it up now. This has been Mark from LongIslandWatch.com, showing you how to regulate a Seiko at 7S26 movement, but you could really expand that to regulate almost any movement. I guess if you wanted to, if you're brave enough, you could regulate the Rolex. I personally would never take the back off, even though I have the tools to do it. I am just too chicken. Anyway, please like this video if you enjoyed it. Please subscribe to our channel if you have not done so yet. If you have any questions or comments, please leave them down below, and I'll be sure to address them as soon as I can. Thanks for watching.